In this example, we've been asked to determine the exact value of cos of pi over 3 minus pi over 4. So the first thing we're going to do is state the compound angle formula for cos of x minus y, okay, because that's what we have here. We're going to have my x there, it's going to be this guy, and I'm going to have my y, which is that guy. But let's state the general formula first. So that's going to look like cos x cos y plus sine x sine y. And now I have all of my y's and my x's for me to put both my pi over 3 in for x and my pi over 4 in for y. So let's do that here. This is going to look like cos of pi over 3 cos of pi over 4 plus sine of my x, which is pi over 3, and sine of my y, which is pi over 4 here. Beautiful. So because we are determining the exact value, I need to individually find the exact value of cos and sine of pi over 3, as well as the cos and sine of pi over 4. But that's what we're going to do here and here. Okay, I'm going to deal with the x value first, where x is pi over 3. So I'm going to do that right here. So to find the exact value of this, my first step is to draw it out. So pi over 3 will look like that. This here being pi over 3. My next step is to connect it and label this lovely special triangle that we have now. And since this is pi over 3, that means this is going to be a 1, 2, root 3 triangle. Well, that means my 2's always live on the hypotenuse. Okay. And my pi over 3, my little trick to remember that is it is opposite the root 3. 3's got to stick together, which means this guy right here is 1. Okay, so my first step was to draw. Second step was to connect and label. And now my third step is to state my two ratios. Okay, well, let's not forget that sine of theta deals with my y value, so that's my y over r. And cos of theta deals with my x's, so that is my x over r. Okay, so those are the ratios that hopefully you guys have memorized. Okay, so let's figure out what's what. Well, this is my x, this is my y, right, because that's the x component, the horizontal, and this is my y component, the vertical, which finally makes this my radius, my r. So now let's state my answers. Okay, well, I'm going to have sine of pi over 3, and sine is y over r, so that means it's going to be my root 3 over my r of 2. Cool. Well, what about cos of pi over 3? Okay, well, cos is my x over r, and my x is 1, and my r is 2. So now I have both sine and cos of pi over 3, so I'm going to have that one now and that one. But I'm not quite done because I also need sine and cos of pi over 4 now. I'm going to do that one down here. So this is going to be my y equals pi over 4. I'm going to do that one right here. So first step, draw it out. This one's going to look a bit like that. Here's my step 1. Step 2, connect to make my special triangle and label up my sides. Well, since this is a pi over 4 triangle, or pi over 4 angle, that means this is going to be a 1, 1, root 2 triangle because pi over 4 is the same as 45 degrees. So when I go to label my sides, the 2's are always on the hypotenuse, always. Doesn't matter what kind of 2, the 2's are always there. That leaves this side and that side to be 1. So that's my step 2. I've connected and I've labeled my sides. And finally, I need to state my answers. So my cos of pi over 4 and my sine of pi over 4. Okay. So since this is my horizontal, this is on the x-axis there. This is my vertical, which is the y, and this is my r. Well, cos is x over r. So my x is 1 over my r of root 2. Actually, my sine, y over r, was also the same. But we've got a bit of a problem for both of these here. Okay, they both have radicals on the bottom, and we are not allowed to have that. So that means I have to multiply this by something, which we're going to do essentially multiply it by 1, or something that would have canceled to be 1, that holds the integrity of this original answer. So I'm actually going to multiply this by root 2 over root 2, because that would have canceled to be 1, which gives us the same answer. And the way I chose root 2 is because that's what's on the bottom here. That's the thing giving me a problem. I'm going to multiply it by whatever is giving me the problem. But I have to do it root 2 over root 2 because that is just 1. So I'm still holding the original answer here. So when I do that, this will multiply out to be root 2 over 2. And that is proper math form. Okay, so that's actually going to be the answer for both of these. So I multiply that by root 2 over root 2 to give me an answer of root 2 over 2. That is the proper math form. This, like in English, it's like a incomplete sentence or poor grammar, right? It could still make sense, but it's not proper, right? We are adult mathematicians now, so we got to do it up right. But now I have both my sine and cos of pi over 4, so I have everything I need. So I'm going to plug in my sine and cos of pi over 3 and my sine and cos of pi over 2 back into my original formula. So what do I get? Cos of pi over 3 was 1 over 2. Cos of pi over 4 was root 2 over 2 plus sine of pi over 3, root 3 over 2. And finally, sine of pi over 4 down here is also root 2 over 2. There we go. Now, all I have to do is clean it up, simplify to get our final answer. So when we multiply fractions, we multiply the tops, multiply the bottoms for both. So that will leave me with root 2 over 4. And I'm actually just going to leave this as root 3 root 2 over 4, and you'll see why in a second. Because now I'm going to be adding two fractions, and luckily my denominators are already the same, so I can just add the tops. Now, I could leave this and be correct, but again, we want to simplify, clean up as much as we can going forward so that it's easier if we have to use this down the road. Because I look at this term and I see something in common. Well, I'm actually going to common factor out that root 2 out front of the numerator, leaving me with 1 plus root 3 all over 4. And that is the cleaned up, beautiful, proper way to answer this question. This is the exact value of that statement there.